Hello, and today we will be discussing insertion sort, a sorting algorithm that is similar to, but slightly more efficient than bubble sort. Like bubble sort, insertion sort repeatedly compares each two sequential elements in an unsorted array, but what separates it from bubble sort is that the code checks the order of previous elements and sorts them during a single pass. So this will make more sense if it's explained in an example. So let's just take the simple array of 3, 2, and 1. So we have an array 3, 2, 1, and 1. And now, much like bubble sort, we're going to check the first two elements. So we check the first two elements and we compare to see if the left element is greater than the right element. And we see that 3 is greater than 2. So we do a swap. All right, now we swapped and we have 2, 3, and 1. So now we go on to the second iteration and we see that we compare the next two elements and we see 3 and 1. Now 3 is greater than 1. So we swap. And when we swap, we get 2, 1, and 3. All right, now how does this differ from bubble sort? Well, in this same iteration that we say that 3 is greater than 1, or we're checking 3 and 1, now we're also going to check the elements before that, the previous sequential elements. So now since we're checking the previous sequential elements, we're checking the first and the second element again in that same iteration because we just checked the second and the third element. So now we check the previous sequential elements, which are 2 and 1 in this case, and we see that 2 is greater than 1. So since 2 is greater than 1, we do a swap, and we get 1, 2, and 3. And so the reason this is more efficient than bubble sort is because we're checking those previous elements to save passes. We don't need to do another pass on the array to sort it because we're doing it within a single pass. We're checking those previous elements within a single pass. So now let's look at the code. So this is the code for insertion sort. And we have our unsorted array right here. It's just variable A and it just consists of 5, 4, 3, 2, and 1. Pretty simple. Now we have a loop right here that goes from 1 to array.count minus 1. And we have this variable j equal to I. And this variable is crucial to this program because essentially what it does is it allows us to check previous elements, previous sequential elements within the array. And it's crucial to the program because it's what makes it different from bubble sort. And this will make sense in just a minute. So now we have while j is greater than 0 and a of j minus 1 is greater than a of j. So that should look familiar because in bubble sort, we said that a of j minus 1 is greater than a of j was the same condition that we had in bubble sort as we're checking the left element and the right element. And the left element is a of j minus 1 and the right element is a of j in the array. And now we say that while j is greater than 0 and the left element is greater than the right element, then swap both of the elements and we decrement j by 1 in this line right here. And essentially that's all of the code for insertion sort. So let's go through one iteration. I'll just pull up notes here really quick. All right, so now we're saying 5, 4, 3, 2, and 1 is our array. And so first, what are we doing? So we have this variable j equal to I on our first iteration. So j equals I and I equals 1 on our first iteration. So I equals 1 because we're going from 1 to array.count minus 1. And so since j equals I, j equals 1. All right. Pretty simple so far. And now we have a while loop. So while j is greater than 0, is 1 greater than 0? Yes, it is. So that's good. And a of j minus 1, so a of 1 minus 1, a of 1 minus 1 is essentially a of 0. A of 0 and is greater than a of j. So, or a of 1 on this first iteration. So is a of 0 greater than a of 1? Well, let's see. In our array, we have 5, 4, 3, 2, 1. Is 5 greater than 4? 5 is greater than 4. So we pull a swap. And then we decrement j by 1. So j was 1, j minus 1 equals 0. And we're still in that while loop. So we go again in the while loop, but we need to check our condition. So while j is greater than 0, 0 is not greater than 0. So 0 is not greater than 0 because 0 equals 0. So we don't go on our second iteration. We don't go in the while loop continuously. We get out of there and then we go to our second iteration. So after our first iteration, we are left with 4, 5, 3, 2, 1. Because we swapped 5 and 4, and then we exited our while loop. All right. Now on to the second iteration of this loop right here. And on our second iteration, I equals 2. So j equals I, so j equals 2, so j equals 2. 2 is greater than 0. Now we're checking a of 1. And we're seeing if that's greater than a of 2. So is a of 1 greater than a of 2? Now a of 1 is 5 and a of 2 is 3 because we're checking our second and third element. And we see that 5 is greater than 3, so we swap. And we have 4, 3, 5, 2, and 1. Now we'll actually be able to see the magic of insertion sort. So now we decrement j by 1. So since we decrement j was 2, j equals 2. So 2, or now j equals 2 minus 1 because we said j minus equals 1. So j equals 2 minus 1, which equals 1. And we check the condition on the while loop again, and we see that 1 is greater than 0. So we're good there. Now we have to check if a of 1 minus 1 is greater than a of 1. So is a of 0 greater than a of 1 now? Well, what we have so far is 4, 3, 5, 2, 1. And essentially it's checking the first and the second element because a of 0 is the first element and 1 is the second element. 4 is greater than 3, so we swap. So essentially, j decrementing by 1 allows us to check previous sequential elements. And this while loop is the reason that we can just keep on going backwards and checking our whole array as we go through each iteration of this loop right here, this top loop. So now, since we swapped those, we have 3, 4, 5, 2, 1. And we keep going now. Now j will decrement once more because we just swapped. So j was equal to 1, and now it's going to be 1 minus 1, which is 0. But we know that this while loop only continues while j is greater than 0, and 0 is not greater than 0. So we go on to our third iteration of our top loop, and I will be equal to 3 now, so j will also be equal to 3. J equals 3 now, and we are now going to compare a of 2 and a of 3. So that's our third and our fourth element. So we have 3, 4, 5, 2, 1. We're comparing our third and our fourth element, which are 5 and 2. 5 is greater than 2. So we swap. 3, 4, 2, 5, 1. But we had j equal to 3 now. So now we decrement j again. So j equals 3 minus 1, which equals 2. So now we compare a of 2 minus 1 and a of 2. So that's our second and our third element, right? Because we're seeing if a of 1 is greater than a of 2. A of 1 is 4 right here, and a of 2 is 2. And so 4 is greater than 2. So we swap. Now we have 3, 2, 4, 5, 1. And then j will decrement again to be 1. And then we check the first element and the second element now. So we check 3 and 2. 3 is greater than 2. So we swap. And we have 2, 3, 4, 5, 1. All right, now everything is sorted but this 1 here. So what's going to happen? All we need is just one iteration, right? Because this while loop will take care of that 1. This while loop will essentially sync that 1 to the beginning because 1 is the least number in this whole array. And so j will just keep on decrementing and we'll keep on checking the previous 2 elements. So we'll be checking 1 and 5 and 1 first. 5 is greater than 1, we'll swap. So we'll get 2, 3, 4, 1, 5. And then we'll be checking the previous 2 elements, which will be 4 and 1 in this case. 4 is greater than 1. So 1 will go here. And then 1 will just keep hopping essentially. And after that, it'll finally come to 1, 2, 3, 4, 5. So let's put notes to the side and let's run our code. And these print statements are in the while loop and outside of the while loop. So we're printing every single time that we're going through either this while loop or this these outside iterations. But if we just look at the iterations of our outside loop, so if we just take this and delete this, we run. We can see that we have 5, 4, 3, 2, 1, and then it goes to 4, 5, 3, 2, 1. And then it goes to 3, 4, 5, 2, 1, because we swapped 5 and 3 and 4 and 3, because 5 and 3 goes to 4, 3, 5, 2, 1, and then 3 and 4 swap to 3, 4, 5, 2, 1 right here. And then we kept on running the code. We got 2, 3, 4, 5, 1. And then finally 1 was at the last element in the array. So it's sunk all the way to the bottom because of insertion sort in one pass. And that's insertion sort.